So welcome to this virtual interim, second of the series. Today we discuss mostly new proposal for blockwise transfer and related work started some time ago on non-traditional responses. And as first main item, in fact, we have a presentation from John and Mohammed on the new draft.
Okay, well, I'll start by doing that. Share my screen.
The audio is not great.
I don't know quite why that is.
It's good now. Thank you.
It's better, yeah.
Maybe just move the thing. Okay, so this essentially is to talk about some of the challenges that we had within the DOTS environment, the distributed denial of service threat signaling type environment, and we came up with the fact that when we're working within networks that are potentially lossy because of the DDoS attacks, some of the existing co-op stuff that's in place there, we need to look at and modify. So here we just have kind of a schematic diagram of where we have this is a use case, there are other ones as well, where we have a client at the end of an internet pipe, the internet, and we have some sort of upstream server who gets with the DOTS client on the local device and provides mitigation services based on information that's passed backwards and forward. And so essentially where the application is using CBOR across CoAP across DTLS. And by and large, in that when the client says, I need help, he will send it as a non-confirmable mitigation request, and the server periodically can update the client with what's going on, again with non-confirmable stuff, primarily because the inbound pipe may be overloaded due to a DDoS attack. So with that kind of scenario, in the normal circumstances, we can handle stuff, the client still can request mitigations, and hopefully the mitigation service is then able to kick in and control the traffic down the pipe so that the pipe is then back into a normal, able to be used type environment.
Sorry, John, maybe allow me to interrupt, please. Is it possible to have the audio just a bit better? Maybe getting closer to the mic, because right now it's a bit wavy and I cannot really capture everything on the minutes.
Okay, is that any better?
Yeah, that's much better. Thank you.
Yeah, I just moved the microphone. Yep, apologies for that. Okay. So the general kind of operation for DOTS is that for configuration, we actually use confirmable CoAP, and this is done in the peacetime when there is no attacks taking place. But for the actual mitigations and responses, everything has to be non-confirmable, as I mentioned before. And we have found that in the general case that a single packet contains all the necessary information. So a mitigation request can be in the packet, or some sort of status update coming back from the service can be in a single packet. And we have found and have done testing that this works fine with packet losses. It just is that the client may not see some of the information getting back. To make the protocol robust, we have what's known as application heartbeats, which do some sanity checks of what's taking place. And through the way that we've done it, the server component out in the internet is able to identify that the client is always alive, even if there's traffic loss, but the client may just have to carry on blind, assuming that the server is still there when there's traffic loss. We then come to want to extend the capability of just a simple mitigate help me type request, and this is what we're doing type response to telemetry. So it could be that the local client is relatively smart and is able to identify why traffic coming in is causing problems. And so is then able to send some sort of telemetry information about what he's perceiving the attack is upstream to the server to enable the server to better mitigate what's taking place. Likewise, the server can send back information about how it's mitigating the attack, what type of attacks it's seeing, and so on. And the consequence of this telemetry information is that we're going to be larger than what can fit into a single packet. In the environment without a packet loss, block 1 and block 2 work perfectly for sending the stuff up to the server and getting the information back with a non-confirmable. If it was confirmable, it works, but if there's any packet loss, we have to retries and so on. But typically with packet loss, block 1's response saying, give me the next one, gets lost from the server coming back to the client, or the server, when he's sending block 2's downstream, the packet gets lost and there's no easy way of recovering for that. And what basically happens within the environment is that everything kind of grinds to a halt whilst we're waiting for things to happen. It's just not acceptable when we're under sort of DDoS attack type environment. So we've been looking at several ways of handling oversized packets. One way is just to use IP fragmentation, so that instead of just a CoAP message fitting into a single packet, we let it go into multiple packets and just send the whole data and assume that all the fragments are going to make it, but we have no way of recovering from missing fragments. Another way is that the application breaks up the telemetry data into chunks of data that fit into individual packets and send those. We have a bit of a challenge there because the Yang any data requires each individual chunk to be full JSON in its own right. So we then have to look at how can we break the telemetry data down into individual fully blown JSON chunks, and then we can do that into lots of very small chunks, but we want to actually minimize the number of chunks or packets being sent so that we maximize the usage of any individual packet that could be there. Using block 1 and block 2, we found has limitations, as I alluded to before. The performance is that if you're sending a block 2 from the server back to the client, the server has to send the next thing, then the client just has to request the next packet. So we've got inter-packet latencies taking place, as we've got turnaround times and all the rest of it. And we fall apart when we're in a lossy type environment, when the pipes are running full, when there is a serious DDoS attack that's taking place. So out of that, we then thought, well, let's propose options, block options 3 and block options 4, which work in the same similar sort of way as block 1 and block 2, but there's several additions. One is that we can send all the block 3s serially one after another up to the upstream server, or likewise the server can send all the block 4s with some sort of major stated message. You can just send them down serially down the pipe, as if we were sort of doing it with fragmented packets. They all just immediately follow one after another. But if we're going to be using block 3 and block 4 in a confirmable environment, then we obviously need to increase end start, which is slightly uncharted territory. Additions to block 3 and 4 is that we can request missing blocks. So if we're missing some data, some packet hasn't got through, we can re-request it. And so that we can make sure that the blocks that create the body of the entire chunk of data that's to be passed down, we've come up with using a block ID for reassembly, but has been a bit of discussion about using ETAG, but we're not entirely sure whether we can use ETAG because it is a resource local identifier. So there's a question mark in our mind whether ETAG would work instead of having this block ID as part of the block 3, block 4 packets. So just looking at some of the block 1 versus block 3. Block 1, we are limited to probing rate. So if you're just sending them out and there's no response because the pipe coming back towards us is running full, we're limited to that probing rate of 1 byte a second, which is, whatever reason, is quite a low rate. So we'll be hanging around for some time doing stuff. So it'll take time for telemetry information to be passed that. Whereas block 3, we would say is subject, the whole body, the whole block of, or the set of blocks of rather, data are subject to the probing rate. So it means that we can just do a quick blat and everything gets to the other end, and then we have to go back into the probing rate type stuff. Both block 1 and block 3 can utilize the 408 missing blocks, the entities not complete type stuff, but we need to extend the message that's in the response of the 408 either with the data body having this is the array of what's missing, or we just include in the 408 response the fact that we've got block 3s and we've seen these blocks and we haven't seen those other type blocks sitting in there. So we just trying to work out ways of getting around that, and that's what we've kind of loosely documented in the draft text. Likewise, with block 2 versus block 4, the server has to wait for the next block request before we can send the next block down, and we have to maintain a copy of the body up in the server for a period of time. Whereas with block 4, the entire set of blocks can be sent without waiting, hence giving a highest performance, highest kind of transfer time just to get the data in between. And likewise, as we mentioned with the block 1 stuff, the client can indicate multiple blocks are missing, and server can delete a body on successful receipt and so on. So we can do some sensible management there. And thinking about this, it makes sense to us the non-CoAP experts, that caches can keep the data at the block or the body level for ease of caching should it be required. We have a challenge with tokens in how they should be used or not used, as the case may be. So essentially is that token matches a response to the request so that the client can work out what this particular message that's come back and hit him is with. If we're going with the block 3, block 4 type stuff, the tokens, there is no more additional client requests going upstream with the block 4 because all the block 4s are coming back. So do we use the same token across all the block 4 responses that make up that big body, or do we have different tokens or whatever? It's the tokens intended to be a client local. In other words, it's under the control of the client, so the server has to send some stuff back. So we've got kind of question marks about what to do with tokens, and likewise, are there any implications in proxies that we haven't yet thought about? We also, which we haven't got into the draft document, anything to do with RFC 8613, which we need to think about. I'm guessing just mark it up that these are similar to block 1 and block 2. I.e. both E and U are set. So that was a kind of overview of what's taking place. We have some questions that we haven't quite got answers to. Is there any sort of comments one would like to make?
I have a bunch of comments, but if someone else has one, I might not stop talking for some time, so maybe I'll put myself at the end of the queue.
Go ahead, Christian.
I think, yeah, Carsten?
Carsten, we cannot hear you. Yeah, Carsten, the audio, we still don't hear you, sorry. Shall we, I mean, Christian, maybe you can start, and then Carsten just jump in whenever the audio is fixed.
Okay, then maybe let's start with one of the smaller items. On the E tag, I don't quite understand what the issue about the identifier being resource local would be. I understand resource local to mean that this identifier is scoped to that resource. That is, it can't be reused between resources, but that's not something that should impede this particular use case.
So from my perspective is that it's something under the control of the server. He is generating the E tag, and it's conceivable that the E tag may be the same for a different set of body blocks. In terms of how, if you compute it, if you're using some sort of weak algorithm to compute it, it's conceivable that the E tag may be the same for different sets of blocks.
I think that's precisely what it says that the E tag should not be. And in those cases of hash collisions or something like that, where it would be, I wonder how the block ID would be any better here.
Okay, so the proposal in the draft document is that the block ID is incrementing. So for each new block set of body set of blocks that are sent back, we'll have a new block ID which is incrementing every time a new body is sent back. So yes, that will recycle around in time. It will be a very long time.
But that's something that could just as well be done with an E tag if the server insists that it, if the server wants to use this particular model.
Sure, I accept that. It could be done the E tag, and it could be cycling around. Yeah.
And on a more general level, did you have a chance to read my mail that I sent this morning on the whole topic?
I didn't see one this morning. I saw a copy of an email that you sent out earlier on in the week, because I wasn't included in the list of people being sent to. So I don't know if there's another one you sent this morning.
Let me check briefly.
Nine.
Okay, so sorry, I mixed things up. Yes, that mail was a bit earlier that week. This morning's mail was just kind of taking the thoughts from there on, but I think that wouldn't affect this discussion too much. So my impression of this overall thing is that all of this can be done without kind of changing the whole block system by partially by mechanisms that are somewhere else in the pipeline, and partially just by finding concrete kind of doing concrete extensions without blocking things on proxies that would be processing it. So, for example, if you could go to the right here it is on the missing blocks re-requesting. This should for the block 3 case or the block 1 case. This should be quite straightforward if there is just a response sent by the server that indicates which blocks are missing at the point in time when it comes to processing that put. So if that is supposed to be done in an atomic fashion, then sure, we would need to define a media format that says this is a reason for a failure to reassemble to act on a message, and it indicates what parts are missing. But with that that could easily be packed into a CBOR array or any CBOR array is probably the most straightforward. Could be defined as a new media type and then just sent back with a block 1. And I think that would then catch most of the block 1 cases that of the block 1 problems that I mentioned so far.
Yeah, sure. Okay, so from your email that I read earlier this week, the slide I've got up at the moment just talks about it being a 408, which is what you were referring to. The question is, how do we include it? Okay, yes, it could be another CBOR.
John, sorry, John, the audio is really choppy, really hard to follow, at least for me on the minutes. If you could just get the microphone a bit closer, because sometimes it's pretty good. Sorry for interrupting.
Yeah, that's okay. No, I just why I'm so quiet on the microphone. I apologize, but okay. So yeah, just is that in the email that I saw earlier this week from you, Christian, which is why on the slide that I have now got up here, we talked about the 408 for the missing blocks, which could be some CBOR embedded stuff, which is how we can handle the block 1 stuff. But my real challenge also is how we do the block 2. And you didn't really come up with alternative methods for block 2. You only really came up with alternative methods for block 1. Appreciated and worth certainly seriously thinking.
Well, for block 2, I think it's really not that different from what block 4 does. The main point is to get the server to send the blocks en masse in the first place, and the token issues that you're stumbling on is kind of the linchpin where this will all resolve around, because this is the tricky part. And however we resolve that, for example, by using non-traditional responses, then the client receives the list of all blocks that are there and can just get the ones that it's missing in a second round.
Sure, I understand that. Okay, so but what I guess what partly concerned me was we are potentially changing the semantics of block 2, which is that a response is sent, then the client requests the next one, and then another response is sent, and so on. And we're changing it to sending them all out in one go somehow. And does that affect the appropriate RFC? Do we need to kind of say this is a modification of that RFC, or do we come up with a option which effectively does what the block 2 does, but with some enhancements.
So I don't even think that this so much needs to be an extension to block 2, but more to the general token mechanism. And then be a very lightweight or even absent indicator that, yeah, and please send me more blocks if you have any.
Sure. Well, certainly the server needs to know somehow that instead of sending block 2 one by one, as is requested, he's going to have to send them by a block. So there needs to be a negotiated agreement that he's able to do that. The server is able to send them all in one go.
Yes.
And yeah, so we again in our draft have said that if the client initiates the GET request using block 4, then the server, if he understands block 4, he knows that it is safe for him to send all the block 4s as a big watch.
Yeah, but that that still leaves us with 2 mechanisms where I think that one that has a small extension can suffice here, and that one mechanism and that extension could be generally used for other purposes just as well. Carsten?
Carsten, we can still hear you. Okay. Christian, you can resume.
Yeah, just picking the. So I think that if we combine all those building blocks that we have or might have if we continue on the non-traditional responses, then the only thing that remains is that we would not have a mechanism for I missed many blocks and precisely I need this and that and that and that one. So is this something that you expect frequently to happen? Because the examples that you had in there all were about bursts of missing blocks.
Yeah, at near pipe full conditions, it's conceivable we may randomly miss several blocks and have the ability to re-request the missing blocks. It certainly is a possibility. I agree that in the really flooded condition, certainly with block 4s coming back downstream to the client, we're likely to miss all of them. And certainly within the draft, we have that is up to the client as to whether he decides to re-request missing blocks or just say, okay, well, there's just too much of a loss going on here. Let's just carry on and wait for the next set of data to come in my direction.
Yeah.
So does anybody hear me now?
Yes.
Okay, well, it reconnected me. So just for everybody's amusement, Michael Richardson has found out that if you are on the internet, WebEx doesn't work. You need to be behind a net. And I didn't remember that I was on the internet when I started the call. So yeah, very, very interesting. So what I was suggesting was that maybe we can structure this discussion into a number of items, and I may not be catching all of them. But one big item, of course, is congestion control. And we need to understand what we are doing here. And maybe a meta item behind that is, are we doing something that is very specific to dots? So are we kind of ignoring that there might be other applications that have similar requirements for their application? Or are we trying to build something general that will work in other places? Because with dots, of course, the idea of applying congestion control to a DDoS situation is never going to work well. So we probably have to build something that actually actively cuts through excessive congestion. So that makes the solution probably look different from solutions that are generally applicable. So that's one thing, or one and a half things. And the other question, of course, is what is the proper way to extend the CoAP model here, which was not designed to be optimized for performance in the block situation. And so far, the general idea has been, if you need performance for large objects, then run CoAP over TCP. But there are good reasons why we don't want to do this here as well, which is maybe another observation that we are designing something here that is somewhat specific to what DOTS does. And getting some progress on the non-traditional responses, that would be actually be great. So we would have something coming from this which is generally applicable and can be used in other situations than DOTS, maybe with some congestion control added.
Do you want me to kind of respond to that, or Med, do you want to make a comment?
Yes, please, but maybe the whole working group has an opinion on that, but I'm sure interested in your opinion.
Okay, so yeah, totally agree that there's some very DOTS specific type stuff here because of the potentially nasty environments that we work in. But I do think that there will be other people using UDP where there are potentially lossy networks, where there is an occasional packet that gets dropped. This is one of the reasons why we perhaps use UDP, so that we don't care too much if something gets lost. Like the old IP fragmentation challenges, is that you always got 9 out of 10 packets, but you missed the 10th in an environment that was giving problems for whatever reason. So from that perspective, having the ability to send more data quickly, so we can get it over an environment, I think it's a more general case than DOTS, but I agree that it's certainly generated by what DOTS is doing. Again, with DOTS, TCP is virtually a no-no because you just now if there's any loss at all, TCP goes into recovery, things slow right down and can potentially just give up. We just cannot afford to have the client choking on a TCP connection, saying, I want to be able to mitigate something because the TCP stack layer is not working. Yes, we have TCP within DOTS, but it is a backup rather than the primary use, which is UDP.
Yeah, so to get this by the ISG, we probably have to make sure that we don't sell this, hey, if you want to do something aggressive, ignoring congestion control, then CoAP is the protocol you want to choose. Even though it is exactly that here, but I think we have to be a bit careful here, or the transport people will roast us on a spit.
Certainly, from a DOTS perspective, we want to obey all the probing rates and all the rest of it. The individual bodies of messages should be subject to congestion control so that we don't overload the circuits. It just is that we need to get a larger chunk of data, larger body of data made up of chunks moving in a direction at any one time. But that body would be subject to things like probing rate and so on, which is absolutely right. Otherwise, we'd create a DDoS attack in its own rights just by using the DOTS protocol, aggressively sending too much data down the pipe.
That's confusing me.
Go ahead.
That's confusing me a bit because if DOTS gets licensed to send arbitrary amounts of packages, ignoring the probing rate, that sounds much more complicated to me rather than just stating that for this particular situation, the probing rate is this and that might be higher than the kind of default probing rate CoAP specifies, if, in case you don't know any better. So how is this better than no probing rate at all?
So you have a set of blocks which comprise the body, which is 3 or 4 packets. That entity is allowed to be sent, and then when the next entity wants to come along to be sent, it is subject to the probing rate, which currently is 1 byte per second, which is quite low, but that's another story.
Yeah, but couldn't you just increase the probing rate if you want the bunches of 4 packages to go through in one go by a factor of 4, and then just and still respect the probing rate on average, but still send them as a burst? I think the probing rate is meant to be followed on average and not kind of on a byte per byte level.
Okay. Then yeah, then the probing rate as an average, yeah, we would adhere to that, because we certainly do not want the DOTS protocol to create a DDoS attack in its own rights. Absolutely not.
Yeah, again, I think we need to consider the two directions separately. So the direction that is subject to DDoS at the moment, you essentially need license to cut through. There is no way to do this in a TCP friendly way or something. So jumping probing rate to a high number while this is going on might be a way to do this. Still, you don't want to send your packets faster than your link is. So that there is maybe it's possible to remember something like a good rate and use that as a probing rate. In the other direction, we don't have DDoS going on. So I think there is still some incentive to do this in a friendly way, even though it's certainly priority traffic in a certain sense. But it never makes sense to send packets at a higher rate than the network can actually transport it. So that's why you need congestion control, even if you are alone on a particular path. So getting something going there would be nice, but then congestion control needs feedback. So how do we get feedback if the packets are lost in the other direction? I think that's an interesting question. Is there a good way to get feedback for the direction away from the DOS network that allows us to do this at the highest rate that makes sense congestion-wise?
It's a way of detecting at the case of up here, the client end, detecting that there's a loss of traffic coming down the pipe from as part of the DOTS protocol. From there, he can then provide some sort of feedback outbound saying, I am losing this amount of traffic. That would be a telemetry item that would add to the protocol. But that isn't, again, in the general CoAP environment. This is an application-specific thing. Telemetry that's going back. The ability to be able to give feedback to saying that the traffic coming down the pipe inbound from the internet to the client, there is a loss, and we have a way of indicating that loss back up. And that could be a CoAP option in its own right, talking about some sort of determined loss if you wanted that kind of thing.
I suppose that could even be part of the telemetry that you're sending and would not need to be made into a new CoAP option at all. So if the telemetry that the server sends to the client indicates has some information that goes into the algorithm that determines the probing rate for the client. That wouldn't, I mean, that would be dot specific, and that wouldn't, in my opinion, need to be in a co-op option, but it could just as well be in the generic telemetry that's in there. But
absolutely, yes. You know, that we can pick up that kind of stuff. We certainly, as part of the telemetry, we're able to configure what we believe to be the different pipe sizes and so on. You know, we're on a 100 meg circuit or 50 meg circuit or whatever it may be. So we're able to pass that information between the client and the server, which helps the mitigation process know that he's only got a 50 meg pipe. He can send stuff down. Everything has to be controlled to that size or whatever it may be. We do have the application layer capable of handling that kind of stuff. Certainly, if we had the concept of a block ID, whether it's in ETAG form or block ID form, the client, when he's seeing the block 4 stuff come back, he can tell if he's missing blocks, rather bodies of blocks. He can see that he's only getting 1 in 10 of them getting in his direction or something. He's able to feed that back up via the DOTS protocol to the server, etc. Or that could be something that CoAP, if we want to have the congestion control feedback as part of CoAP, could feedback.
So that might be one component of the solution, that we essentially define a way for CoAP to run with external congestion control input. So the CoAP machine does not have to itself find all the congestion control information. It gets some additional information from the application, which has more information available to it. So that could be one way to solve this congestion issue, and then we could focus on the protocol issues.
I agree. Any other input on that?
just that I like the separation of kind of doing flow control that's probably dot specific, because that would also free the rest of the discussion of the kind of the oddities of the particular situation, and help us get a better generic solution to the rest of the issue.
Please, Klaus.
I'd like to throw in a slightly different perspective. What we have right now is co-op over UDP and DTLS, and we have co-op over TCP and TLS. And when we started with the co-op over UDP 10 years ago, we tried to keep co-op as simple as possible. And what we did in the beginning was that we tried to get away with not even having confirmable messages and acknowledgements, or even specify congestion control for co-op over UDP. And somewhat reluctantly, we put those features in. Confirmable messages seemed to be a good idea, but of course the cost was that we now had this additional messaging layer between co-op request response and UDP. And of course, we couldn't get around defining congestion control for co-op UDP. And for that, we followed the RFC on UDP usage guidelines, which had different recommendations based on if you have round-trip times available or not, and so on. And I think we modeled congestion control mostly after the case that was called low-volume applications. And then, as Carsten pointed out, we noticed for some people this co-op over UDP does not work. If you have large payloads, for example, then you might want to have something more sophisticated. And with co-op over TCP, we have such a solution. And so the idea, as Carsten said, was if you need something more than this simple congestion control, simple retransmissions, just use co-op over TCP. And now, 10 years later, things have changed a bit. We're not talking that much anymore about 802.15.4 networks. Maybe our constraint devices have also grown a bit and more like Raspberry Pis today than ARM Cortex M0s and so on. And it's always great to see when a protocol can adapt to use cases and scenarios that weren't envisioned in the beginning. Now, in some cases, the use cases get pretty far away from the initial use case, and at some point it starts hurting a bit because of some initially designed limitations. And in that case, we have a dilemma, and that dilemma is always, if we just add this one tiny thing, then we can support a new use case. But if we add one more tiny thing, and one more tiny thing, and one more tiny thing, then at some point we get further away from the initial design goal of having a really simple protocol. If you build a web browser, and you think you really need this blinking text, then you just add this one more thing of an HTML tag that blinks your text, and you're done. But I think since the name of the working group is the constrained RESTful environments, I think we do not have this luxury here. So even though I desperately want to make co-op useful for more use cases, I'm also always a bit conflicted and think, can we afford this one more tiny thing? And coming back to this draft that has been now presented, my initial reaction was that if co-op over UDP is too limiting because it doesn't fit exactly this use case, and co-op over TCP is a no-no and too big, wouldn't it make sense if we try to build something in between? So if we now have requirements like, just as an example, selective acknowledgements or negative acknowledgements and retransmission windows and DOTS-specific congestion control and so on, wouldn't it be the best solution if we bring this to the transports area? We build something in between UDP and TCP, and then we just define a new co-op transport. Co-op over DOTS-TP, the DOTS transport protocol.
Yes.
Co-op over HTTP.
Okay, so yeah, part of the challenge is that we've almost got the standard DOTS protocol definitions, what have you, are just about to hit the final RFC stage. The RFC number's been allocated, but it's not yet published. So it's not that easy to go back and change all that for a co-op over X protocol. Possible, but it's not. So where we stumbled into this was the extensions for the telemetry to be able to send larger data.
Go ahead, Carsten.
Yeah, I think what Klaus said is quite true, but I think it's also about adding features to co-op that become part of the standard protocol that we would recommend people to use outside the DOTS use case. I think we do have a little bit more flexibility in adding things to co-op, a couple new options or something like that, a few media types. that are really designed to be specific to a use case and come with the appropriate warnings, with the appropriate applicability statement, that they have not been designed to be used in the general internet, except in the situations that DOTS is designed to address. So I think we don't have to go back to the drawing board, but of course I'm still interested in optimizing this to have as much that we can take home from this exercise for the more global CoAP community. And I also think we should not be designing another transport protocol while we are doing this and so on. So keeping it simple is also an important consideration. But in the end, I think it makes sense to build something that is useful for DOTS. And if we have to do this in a way that cannot be transferred one-to-one to other applications, that's also fine.
Anyone else wants to voice their opinion?
Just to double check, Christian, have you explored in a good way for you the alternative use of non-traditional responses as they are now or can be developed?
I didn't really get that question.
Have you discussed good enough for you in a good enough way for you the alternative usage of non-traditional responses as they are now or as they can be developed?
I think that the proposals are in the mails. Discussing them through is probably not on the agenda for today, and I think that the main part that this is the direction this is going is more about the congestion control anyway, and then how to whether one can use non-traditional responses or wants to go block 3-4 direction doesn't help too much in this discussion. So if the outcome of this is that we have something about congestion control and then a block 3-4 that's maybe updated to not interfere with probing rate but just state what it can do, then it would be easier to go through another iteration of what non-traditional responses can do for that.
And I'm willing to then maybe throw another question to the group, like, is the current blockwise transfer, is it sufficient for the cases we have? As we need to define new block 3, block 4, is it worth the while to go back to the drawing board and see how blockwise could be updated? Or maybe it's a bit too early. Okay, Carsten. Sorry, I jumped the queue. I think Mohammed is there, but maybe Carsten, you want to reply to this, I guess.
I want to hear what Matt has to say first.
Go ahead, Matt.
Yeah, actually, I wanted just to comment about the comment from Christian about the problem rate, but I think that you will it's not related to the question from Jaime, so I can wait until you finish.
Okay, so basically, I think we have identified two things that hurt here. One is that the block protocol is entirely lockstep. So you have to receive the next request before you can send another response. So doing something that is somewhat related to observe, but is not about observing a resource, but is about eliciting the blocks of something. That's probably a useful thing to have. And the other thing that I think we have identified is that we need some form of selective acknowledgement mechanism, because we cannot work with a one acknowledgement packet per data packet situation. So this is kind of the inverse of what I just said, that if we can get something like a bitmap back, which blocks have made it, which haven't, that would be a way to solve that problem.
At least in one direction, I think we already have the selective acknowledgement in that we can work with no response requests.
How does that work?
I mean, I don't think that there's anything that would stop a client from kind of say putting the first block, then putting a few other blocks in a non-request with no response in the success case, and then put the say 10th or 20th block in a con again and see whether the server complains or not.
Interesting. I think that would be worth writing this up.
It is in the last mail in the review mail for the dots case.
Okay, I have to read that. So how does the site that is sending the blocks know which ones have arrived?
It knows, well, in the end, it will need some concrete payload in the 4.0 something. I don't have everything to process this response.
Yeah, I don't quite understand how 4.08 fits into the protocol flow, because 4.08 is a final response to a request. So you can't really do much when you have got that.
Can't you? I mean, if you got a say 503 somewhere in between a block request, you could still try to resume later. So why not on a 403?
I think I need to see a fleshed out example for that.
I can provide that.
Yeah, so what I was trying to say is that something like a SEC for this situation, a selective acknowledgement for this situation, is exactly what we need, and we essentially have to come up with a data structure that represents that. But we also have to understand how in the protocol flow, how the protocol flow makes use of that data structure. So who sends this, when, why, and so on.
And in my opinion, the co-op request response layer is the wrong place to do sex.
Yeah, I certainly agree with that from a theoretical protocol purity point of view. But I still think it we should explore whether it can be done and whether the shape of what we get is not just ugly, but has some actual problems that would stop us from using it. I mean, sometimes much of the internet is built out of hacks like this. Yeah, to me it seems it makes sense to write up some of these flows in a little more detail. I couldn't quite make out of new block what the protocol machinery behind these flows was going to be. So maybe if we get a little bit more detail into that, we could find out whether we can solve it that way.
Which for the details, Carsten, you are referring to?
So how do the two ends of the communication know what they are supposed to do? Do we have all the negotiation information, the protocol progress information and so on available that you can actually write code that does this? And preferably code that is not entirely different from how you would do CoAP in the first place.
I haven't done any specific coding with block 3, block 4, but in terms of the coding that I have done that's currently using block 1, block 2, I don't see any challenges in there. As I said, in terms of the block 4, providing the client sends the block 4 to the server, he knows that block 4 support is available, and therefore he can remove lockstep requirements to send blocks, and he can just send the set of blocks in the sequential chain and then go into the recovery after that. I haven't been thinking through, because I know the new block stuff draft that came along, it has been modified a little bit from our new block discussions based on the new block discussions and thinking things further through from a coding perspective. Block 3, block 4 draft has come out of. I don't expect any coding issues that require anything else to be changed in CoAP other than the support of this particular option.
There were a few vague statements about tokens and so on that I couldn't quite understand.
Okay, so yeah, it's really is when one needs to provide a token, then we had discussions about empty tokens and so on. But the token that is provided on a block 4, set of block 4, should it be the same token, which is what's controlled by the client, or should it be individually generated tokens randomly, which is against the whole spirit of things, which is why in the block 3, block 4 draft, I had them all at the same token, as having the same token, to kind of remove that ambiguity there. So that it followed how existing CoAP type stuff does things. Namely, the client initiates a request, there is a token, he then gets back 10, 20, 30 block 4s, which make up a body, all with the same token, and he can assimilate them back into the same response.
So the extended lifetime of the token would be a lot like the way Observe uses tokens.
Yes.
But then we also need to understand when the token finally is retired.
Yes. Well, the token is finally okay. So when the GET request is done, he uses a token, at which point the responses come back with all the blocks. If the GET request does an observe at the same time, or initiates an observe at the same time, then the token is remembered by the server for a period of time that the observe lasts for. There is a possibility that the client will be cycling through lots of requests and hence lots of tokens. There's a potential clash with what's sitting there as part of the observe. We have the same situation just even with single packet observes coming back. There's no difference there as to what we're doing. We'll have that potential same clash.
I wouldn't phrase that as a clash, more as a situation where the client is running out of usable tokens.
Fair enough, yeah. I am not a wordsmith. You guys are. Yes, I agree.
How do you do that?
With difficulty, but it's the client just needs to know that he's asked for lots. He's using his tokens, and that he has an outstanding token that's being used for outstanding observed requests. So the client should know and maintain tokens for this list of tokens for this list of observed requests that he's done. Whenever the appropriate observed response comes back, he knows what to associate it with. So he will be maintaining a list of tokens which are already allocated against observes. Should be. And then he just uses other tokens for his other requests over time.
Right. So it's hard to run out of tokens because there are 2 to the power 64 of those.
Yes, agreed.
Maybe I didn't understand what the point was. Of course, you need to keep track of your outstanding requests. So there is no way around that. And storing a token with the outstanding request shouldn't be too hard.
Right.
The question really is, when do you actually retire a request?
Okay, well, we by and large, we use observe, and so it's retiring the observe. But in terms of when a request retires, okay, so we send off a request, and there are 10 blocks that can come back, and if we have all those 10 have the same token, we may get 9 of them back because of a lost environment. We can either re-request the missing 10th item, or we can say we're going to ignore any further responses coming back. We use that token for other purposes. So the difference is that the request, a single request with the token, we may get back multiple responses for case without observe with the same token. I guess that's the difference. That is a difference. But the block 4 is coming back, and we'll see that it's a block 4 option buried in the middle there somewhere. And so we'll know that we're in a block 4 situation and are expecting more of the blocks to come back.
Right, and the request that would be sent out to get the rest of the blocks,
I would say needs to use a different token, so that it follows the standard co-op rules, that if there is a subsequent request, in the same way that we have block 2 has a subsequent request from the client, he uses a different token.
okay. Yeah, I at least think this can be made to work. It may not be beautiful, but yeah. So my problem really probably is more with the current text that doesn't explain all the things that we seem to have in mind here.
Sure. Well, certainly Med and I will go back and revisit the draft based on the discussions we've had today, and come up with again more documenting some of the sequencing and so on, as well as more clarity as to who uses what, where, and how.
Okay, so we probably need this applicability statement. We need some way of saying there is congestion control information outside of CoAP that goes into this process. we need the definitions of the block 3 and block 4 options, and we need the data structure that does the selective acknowledgement or the selective re-request.
Yes.
I think that's the list of things I have in mind right now.
Yes, some of this information is already in the draft, but we will rework them to make them more clear.
So, Christian, what do you think about what I just said?
I still think that it would be more elegant to solve this by just using a more generic phrasing of non-traditional responses. But if it's kind of if it turns out that is more complicated and slower, and this is just what we need for this very particular use case, yeah.
Yeah, so I think we should simply true both in parallel. So do the very, very specific, very limited solution, but also think about a solution that has has a broader scope of applicability. And at some point, we need to decide which of these we actually do. So how much time can we give ourselves for doing that? And that was mostly a question in the direction of the dots people.
Okay, in terms of time, in terms of the block 3, block 4 stuff, couple of weeks max. I would expect less than that. In terms of the non-traditional responses, I need to think quite a bit about that, because that is more kind of unsolicited non-traditional responses, in that the server can elect to send something because he feels like it, whatever reason, rather than it's kind of there's an element of observe in there, and that you see, if something happens, then you've got to send this data, but it doesn't at the moment, in my mind, and I need to go back and reread it again, it doesn't really cover multiple blocks of data, unless you view it as being unsolicited, block 1, block 2, block 3 of 10 getting sent as a non-traditional response.
What do you mean by it doesn't cover multiple blocks of data?
Well, in that it talks about, there's this response where we have embedded in there, this is what the request would have looked like had you requested it, and here's the response type stuff.
That would not be necessary for the block responses.
No. Okay,
because they are obviously non-matching.
Yeah, but then for so sending multiple blocks we can have the initial block 2 is sent, and then we can have non-traditional responses, which are the remaining block 2s. They would be subject to any probing rate type stuff, because you're sending them out and you're not necessarily getting a response back, and therefore you don't know whether you're killing the network by overload or whatever. So there's all that kind of congestion control discussion is also relevant to that there.
Yeah, but I think that can be independent. I mean, that should really be independent of which block option one does this with, because this one is an option and the other is kind of the request response, the ACK and con layer of CoAP.
Yeah. Okay. I need to go back and look at the non-traditional one and think about it, how we can take that or extend it in the direction of the specific problem we're trying to solve. So
one thing that I'd like to add here is that if, for example, sending a singular, if giving more indication to the server about what blocks the client wants is something that you'd need. This can be added, but one of the design points for this this leisure for this new option that allows the server to send more leisure for responses option is that all those kind of specifications, like send me this and that block, or don't know, if there is a link over there, follow it and give me that response as well, could be done in such a way that the proxy doesn't necessarily need to understand them.
Sure.
So I didn't add them in there because that's kind of the generic framework, but something like and give me slices from to as well can be an option that I didn't write about yet.
Okay, so yeah, it's you have things that you've thought about that I'm coming in from the cold and haven't yet even thought about, but yes. I certainly, I'm happy to take away and look at the non-traditional response stuff and see whether it can be extended in directions that make sense for challenge we have with dots, which is to get large blocks of data over, but we don't care too much if they actually get lost.
So, I'm also happy to kind of update that more frequently. Procedurally, I don't really know where to do this best right now. I've written a mail because it's basically updating a draft that's not mine, or suggesting an update to a draft that's not mine. It would just help me if Carsten and or Klaus, one of you, could have a brief, just high-level look at the non-traditional response proposal, because if I'm going in a completely wrong direction, you'd probably spot that.
Well, I looked at it and I was going to ask whether you want to be a co-author.
Happily so.
So yeah, my question actually was not so much about how long do we need to do this work, but how much time do we have to do this work? So is the dots universe going to explode on August 31st if we don't have this solution defined, or do we have a year, or what is the, of course, everybody wants everything as soon as possible, I understand that, but what is the realistic timeline for this?
It depends if you want to have this included in the base dot telemetry specification, which is currently, I would say, it's advanced in the, I would say, in the version we have so far. My target for it is to have it in the working group last call by July. So for the time being, I'm really careful to. Despite that we know that this is really, I would say, a problem that we need to solve. So far, we are careful in the usage of the, I would say, there is no normative, I would say, language for pointing to the blocks we have defined so far. So for me, I don't want to add any, I would say, any dependency on the telemetry specifications on something that I am not sure I will get soon. So perhaps we can manage to have an I would say, an update to the dot telemetry itself if we are confident that we will, I would say, carry on the two tracks and then decide whether we need to whether we maintain the proposal with the blocks, or the one about the unsolicited responses. That can be another, I would say, another track to investigate. But ideally, I wanted to have something which can be integrated in the dot telemetry, and I thought that we have done what we have done with the blocks specification is really, I would say, more focused and can be, I would say, progressed in the publication process faster than the unsolicited specification itself. So it's really up to, I don't have, I would say, sorry to not be, I would say, more precise on terms of, I would say, on the milestone, but yes, this is the current situation is that we have a specification which advanced. We have this pending issue about the, I would say, the large unsolicited notifications. Ideally, we would like to have the blocks I would say, options specified, but I understand that the working group, the core working group, will take more time to, I would say, to compare, I would say, the various proposals and then to make a decisions. So yeah, it won't be the end of the world if we don't have this issue. I would say frozen in the current specification. What I can do by July is that if I don't see any progress on this front, I would just declare it as an open issue and say that the current telemetry specifications won't solve that, and this is for future version of the specification. So that's my current take on this.
Okay, thank you. That was a very detailed answer to my question. I think I understand the situation. So I think we have about 6 weeks we can use to play Lego with our various elements of solutions we have in mind, and then I think we should be starting to make decisions.
Mohammed, before you also had some comments on the probing rate itself.
Yeah. For that one, yeah, the comment I wanted to make is that when we are opening I would say, the session between the DOTS client and the DOTS server, we are negotiating also the probing rate that will be followed by both the DOTS agents. So we are increasing the default one that we have currently in co-op. We are recommending to use 5 because there are a lot of overheads there. But once we agreed on, I would say, the probing rate between the DOTS client and the DOTS servers, we are adhering to that probing rate. So we are not being aggressive to what is negotiated on configuration. We are bypassing that congestion control in one exception when there is an attack and we want to place a mitigation request. Apart from that, we are really, I would say, following the average, which is dictated by the probing rate, and we are also following the recommendation we have in RFC IETF 5. So we are not bombing I would say, the network, and we are not just sending messages to the network that the network is able to handle. This is the first comment about the probing rate. There's also one comment that the question made by Carsten about whether we have a feedback from the agents themselves about they are receiving, I would say, some messages. As mentioned by John, we are defining at the application level what we call the herbits. And the herbits, we are including, I would say, an information about the herbits which is received from the other pairs. That's I'm saying that's yes, I'm alive and I am receiving or I am not receiving any herbit from you. So we are also sending a feedback to the other agents in the herbit application itself. So this can be, if there is, for instance, if there is a congestion, that means that in one direction you will be able to send your herbits to the other agents, but you don't receive any ones from the other ones. So the agent which sent the herbits that are lost is aware about the loss because it is also reported by the destination agent. So we have this elementary information which is shared between the client and the server. This is not sufficient for, I would say, managing all the situation, but this is what we have currently in the specifications.
Okay, the probing rate negotiation is part of the document that already went through the ISG, right?
Yeah.
Okay, so we don't have to renegotiate that part with the ISG. I think that's a useful part, and having the heartbeats for additional congestion control information, we would have to check whether that's enough of a measurement to use here. Yeah, so for the under attack situation, you want to have at least a little bit of information about whether the data flow in the non-attacked direction.
Exactly.
The heartbeats might provide that information. So it's a bit like a receiver report in RTP, if you need to explain that.
Yeah.
Yeah, so at the protocol level, at the current protocol level, we don't really have to do much. We just say that there is external input that allows us to do this in a proper way. And we just make sure we stay within those limits provided by the external input. So I think we are pretty safe. But I think, yeah, this has to be written up somewhere, probably in the dots document.
Yeah, we in the next revision of the draft, we will add, I would say, the applicability that you have mentioned earlier, and also this kind of details, so that this can be clearly, I would say, visible in the document.
Sounds good to me. Maybe the question of curiosity, in the current implementations, how do you actually pace sending these nonce?
Sorry, you're talking about with the dots implementations.
Yes, so if you're doing something like block 3, block 4, you have a number of nons, non-conformable messages you can send. And how do you know how fast you should send them? How do you manage that?
Okay, so I was going to be sending them like I would send, or I would expect at the transport layer, a fragmented IP packet gets sent.
Oh,
They just get sent serially one after another at the IP fragment rate, like an IP fragmented packet. I hadn't thought about actually putting any delays in between the individual blocks.
well, that's probably needed if you want to have a reasonable delivery rate. Okay, so that's maybe something that also should be addressed, because essentially the probing rate gives you the pace for that.
As an average overall, yes. So there'll be a set of blocks, and then there'll be a big think and another set of blocks, and the average will be across blocks as they're sent, so that the next set of blocks can't be sent until the probing rate's down enough for the next one to be sent.
How big are these things?
I have seen in my test I've got up to about 5 packets, but it could be larger. We have done some active data reduction to try and reduce the amount of data by having pre-negotiated mapping tables as part of the telemetry information, so that we can actually reduce the amount of telemetry data that gets passed across. So my test is showing about sort of 5 packets at the moment, but you're not likely to go above 10, 15, maybe max. That would be extreme.
I think the argument can be made that in the internet today, you can send 10 packets without any pacing. Yep. Because the initial window 10 discussion has pretty much opened that floodgate already. So I think if we have a way to make sure we stay within that ballpark, you don't need much mechanism there. If you occasionally go beyond that, then you still probably have to do some pacing.
Sure, I think that's unlikely, and we certainly have the ability within the telemetry protocol to do queries which can do data reduction.
Yeah. Okay, when do we do the next of these things? So this was a pretty useful meeting, I think.
I'm flexible, courtesy of Mr. COVID.
So Christian, what do you think? How long do we take to explore the non-traditional response world?
it's hard to tell, but I think that we can come up with something solid within the next 2 or 3 weeks.
So maybe we should target the interim in 4 weeks from now.
Yeah, let's do that.
Would be great.
Yep, works for me.
Great. Thank you.
So overall, John Mohammed, you have enough material for a good revision of the document, I think. And in parallel, the non-traditional responses work can also proceed. Resume and proceed. Okay.
Wonderful.
Wonderful.
Thank
Yes. Okay, I think we are done with this meeting today. And thank you all for attending, and talk to you in 2 weeks.
Thank you all. Bye.
Thank you all. Bye-bye.
Bye.
Bye.